Now let's look at ways that we can prove that we have a rectangle. First one is to start with a parallelogram. So if we are starting with a parallelogram, and we know we have a parallelogram, then all we need to do is get one right angle. So if we have a parallelogram with one right angle, then we're going to get a rectangle. Another thing we can do is if we start out with any quadrilateral and we find that we have diagonals that are congruent, and I'm putting these marks kind of near the middle so you can say that the entire diagonal and the entire diagonal here are congruent, then that means that you have a rectangle. A rectangle will always have congruent bisectors. And once you know you have a rectangle, you have the full suite of all the things that you had with the parallelogram, plus the fact that you get your equal diagonals that do in fact all break each other in half, bisect each other. You have the side lengths. You have 4 right angles in that shape, and all the other properties of a parallelogram. Skip down to rhombus here. In our first situation, we're going to start knowing that we have a parallelogram. So we have a parallelogram. And then what we're going to do is we're going to find that adjacent sides, the sides next to each other, are congruent. They're the same length. Because if we have a parallelogram and we know that these are the same length, we're also going to know that the things across for them are the same, and that's going to give us that all 4 sides are the same. So that's why starting with the parallelogram, finding adjacent sides will give us a rhombus. Another way to find a rhombus is if we have diagonals that bisect all of the angles that they're a part of. So that means that this angle here and this angle here are the same angle because this diagonal is acting as an angle bisector. And then same thing down here, same thing down here, and over here. If all 4 of those are being bisected by the diagonals, then we get a rhombus. In our last example here, if we again start with a parallelogram, so assuming we have a parallelogram to start with, and we find that the diagonals form a 90-degree angle with each other, they are perpendicular to each other, then we get a rhombus. So of these 3 different ways to prove a rhombus, 2 of them require that we start with parallelograms. This one here with the angle bisectors does not. And again, quick reminder, when we have a rhombus, we get all 4 sides being the same. We get the opposite angles being equal to one another. We get that the opposite angles bisect one another with the diagonals. And then we get a right angle in the middle at the intersection. We also get some properties with these bisecting each other like we got from a parallelogram, and inherits all of the other properties of parallelograms such as opposite sides being parallel. And that is one of the many different ways that you can use to prove all of these different shapes are what they are based on only limited information.